Okay, action.
Hi, this is Noelia, Lyndon, Wesley, and Jessica, and we are here to tell you about the Junior Nibble, an approved model of the James Webb Space Telescope.
Woo!
We did it.
Kind of.
Sort of.
Go.
Our design is very costly and material efficient. The mirror will be made out of inexpensive and effective reflective material that will cover a much larger mirror than the James Webb telescope. The mirror is made from 32 25 by 25 octagons with several triangles connecting all of them. These octagons will fold into a large rectangular prism measuring 25 by 100 by 50 feet. When folded, the mirror, which is made from heat-resistant material, will keep the telescope cooled and secured. The materials used on the telescope will be as follows. Materials. Mirrors coated in aluminum-sized polyester film e-glass cloth, which is both reflective and can withstand over 1,000 degrees Fahrenheit. The back of each octagon will also have a solar panel, providing energy for the whole telescope. The box that contains the hardware will be in The box that contains the hardware will be reinforced with carbon fiber reinforced carbon, as well as coated in pure aluminum.
The innovations and parts of the telescope include a series of 32 octagons and 48 triangles that will connect and help fold the octagons to its final half-bowl shaped form. Two separate 20 by 20 by 90 foot rectangular prisms, one which contains innards and one which will eventually fall off and revealing the telescope. And three different interchangeable telescopes that can see at different light ranges. These will be X-ray, visible, and micro, and the telescope will be provided by the NuStar, Planck, and AstroSat. There will be the large secondary mirror that will be about 4 times the size of James Webb secondary mirror at 15 by 15 feet. If you were to compare the Junior Nibble to the James Webb, you would be able to see that it has more and larger reflective pieces. These are also octagons, and compared to pentagons, they are allowing more flexibility when the pieces curve. Another improvement is that the material on the octagons, the polyester film e-glass cloth, is very heat resistant, both allowing reflection and protection against the sun. The octagons will have smaller solar panels on the back of them, which will allow the whole telescope to have energy and provide heat resistance.
The cost of the Junior Nibble will be costly, but seeing that NASA is willing and has enough resources to spend over $10 billion on the James Webb, we should be good on price. In a real-world scenario, we would plan to have around 1,500 workers working on this project. These will be anything from janitors, builders, to NASA engineers and scientists. So we plan to pay each one around the average of $100,000 per year, coming to a grand total of $150 million a year for workers. And if the Junior Nibble takes as much time to deploy as the James Webb, this will come to an overall grand total of $3,450 million. This is only in the case that the Junior Nibble takes 23 years to build and test it, which is highly unlikely. As for the actual heat resistance material, it would be quite expensive. The polyester we're interested in and the pure aluminum is also inexpensive, as well as the price for small solar panels. This all included would be around $1 million for the quantity we want as for telescopes, satellites sending data, and general risk. If we spend our maximum goal of money, it will still cost less than half the James Webb's cost.
The satellite instruments will be borrowed designs from already existing space telescopes that can see X-ray, visible, and micro NuStar, Planck, in the AstroSat. These will be interchangeable telescopes that are stored in the previously mentioned 20 by 20 by 90 rectangular prism instead of all on one piece of equipment, allowing for better clarity. These can be easily swapped with the press of a button at NASA, and all will look into the secondary mirror. We decided for these viewing options because the Hubble already saw in ultraviolet and infrared, and because visible is very important to see and we wanted better pictures in this light. Cooling systems will not be a huge problem, as almost all things are coated in both heat and cold resistant materials such as aluminum, which becomes even stronger in the cold, yet like polyester can withstand very hot temperatures.
As you can see by our model, we have 32 octagons coated in polyester E-glass cloth. This is a very heat-resistant and reflective material, making it great for a mirror. As you can see, this is also a very flexible piece of work that can form into a final half-bowl shape. We have a telescope in the middle that can be interchanged by 2 other telescopes in the command hub.
3, 2, 1.
Thanks for watching. #Junior Nibble is bae.
Kill myself.